Welcome to the demo for the AWS Fault Injection Service Lambda actions. In this demo you'll learn how to use FIS to inject faults into AWS Lambda functions, helping you build more resilient serverless applications. FIS currently supports the following types of actions. 1. Invocation, add delay, introduce artificial latency to Lambda function invocations. 2. Invocation, add error, introduce Lambda function invocations errors. 3. Invocation, HTTP integration response, modify the HTTP responses returned by Lambda functions. This demo is based on the Introducing AWS Fault Injection Service Actions to Inject Chaos in Lambda Functions blog post. For the demo we will use the code from the sample application, allowing create, read, update, and delete orders. Repository code deploys application, FIS templates and CloudWatch dashboard. We'll now deploy the application resources by using provided commands in the setup section. You will be asked to review and confirm the deployment of the application components. First, for the FIS resources. Second, for the Lambda-based application resources. Once deployment is complete, you will be provided a list of the API endpoints for your application. Please make a note of them. Now we'll execute the second set of instructions provided to deploy the load testing application that will be used to generate requests to the application. Next, we'll set the value for the environmental variable API_URL that will be used by the load testing service to reach our sample application. Now we are ready to run the experiment. We'll execute artillery load testing service using the instructions provided. Once confirmed that artillery load testing service has started and successfully interacting with the sample application, we will leave it running in the background. In the CloudWatch, we'll check that data is being collected and explore the Lambda function configuration. To work with the FIS, Lambda function has several environmental variables configured, as well as FIS Lambda layer has been added to the Lambda function. Let's also confirm Lambda is being executed. Now we'll go back to CloudWatch dashboard and wait for 10 minutes to build a baseline for the Lambda function execution. That will be data for the application steady state, meaning normal operation. Bear in mind that by default artillery load testing is configured to run only for 10 minutes, which can be changed in the configuration file or you can execute it again once it has finished the initial run. Now we have the baseline. Let's start the FIS experiment. In the FIS experiment templates section you'll find FIS templates pre-deployed. First we'll use the FIS Lambda latency action for Java-based Lambda function. Let's explore this experiment configuration. FIS latency action has been configured to run for 10 minutes, adding additional latency of 2 seconds to 100% of Lambda function invocations. We'll change this to 3 seconds. It will target Lambda functions based in the tag specified. We'll leave the other experiment options as is. Pre-deployed IAM role will be selected for the experiment. CloudWatch is used as logging destination. We'll review the experiment and confirm the update. Time to start the experiment. We'll provide a name tag for the execution. And confirm experiment start. You'll see the current state of the execution as well as resources identified as targets in the Report tab. Experiment details in the Actions tab and more information about experiment execution on the other tabs. Now, let's go back to the CloudWatch dashboard and check how the experiment execution will manifest itself on Lambda metrics. As you can see, our experiment execution impacted latency of the execution, which has been reflected on the client side, artillery latency metrics, as well as API gateway latency and Lambda execution duration metrics. Now, following the same steps, we'll choose and execute invocation HTTP integration error action. This action will inject 500 HTTP status errors into 100 of the invocations. Similarly to the previous experiment, we will run it for 10 minutes. Let's check the artillery execution. You can see that now our API responds with the 500 status errors. We'll wait for the execution to complete, while observing the CloudWatch metrics. As you can see both client-side, artillery invocation metrics, and API Gateways Errors metrics show the impact of the experiment execution with the growing number of errors. Once the experiment execution is complete, the number of errors will get back to the zero. AWS FIS Lambda actions make it easy to get started and ensure that resilience of the workload is regularly verified by applying chaos engineering in the form of fault injection experiments. Thank you for watching this demo.